complex ideas that you have into captivating narratives that will leave a lasting impressions throughout. So to guide us through this session, I warmly welcome the main coordinator of this session, Dr. Nayani Gunawardana. Let's warmly welcome Dr. Nayani Gunawardana onto the stage.
Thank you, Suchira. Very good morning. Research Week 2024 Data Visualization Camp. So this is the second time we are conducting Data Visualization Camp. So this is the most sought after program in our Research Week events. So we are proud to create this opportunity to all of you. So welcome our resource person, Dr. Sandun Dassanayake. Dr. Sandun Dassanayake is a senior lecturer in the Department of Decision Sciences of the Faculty of Business at the University of Moratuwa. Dr. Dassanayake specialized in spatial data science and hold a PhD in civil engineering from Monash University. Dr. Dassanayake began his academic journey at the University of Moratuwa, graduating in 2015. His research interests are in diverse, covering environmental, social, and business events through the lens of spatial intelligence and decision theory. So, dear Sir, Dr. Dassanayake, so thank you so much for accepting our invitation and giving your valuable contribution to us. So, dear participants, I wish a fruitful session and encourage you to actively participate to gain a maximum benefit from this event. Thank you so much and have a great day to all of you.
Good morning, everyone. So I'm sorry I will be covering my face due to obvious reasons you may already have guessed. So I have conducted this session last time with the focus more on the visualization aspects of literature visualizing. But today I'll be focusing more on a picture of a grand scale, which is about, as the theme suggests, how we can communicate science to a broader audience. So to this end, I will just start with the presentation, and then we'll move forward from there. Right. So this is my slide from the, yeah. So I think some of you might be familiar with this slide. I have used this in the previous case as well. So in most cases, we do scientific publications and write science to communicate, not only to a broader audience about who are interested in science, and also to the colleagues and peers who will learn something or contribute to the science from what we produce. And there are certain terminologies and practices that we use in terms of science communication. And this is just one particular meme that I found, which is quite interesting, and I put it there to begin with. Right, so for today's discussion, I will mainly focus on the communication of science in a broader picture, where I talk about the genre of science communication, the modern genre, where we talk about how science has evolved from being just a research paper and a communication that broadens horizons. Now, you might have seen these types of communications in different, I can't see because of the list. Yeah. So, yeah, you have seen these things in journals, like author summary, lay summary, highlights, significant statements. May I get a raise of hands if you have seen this when you are trying to publish something and you have seen this, where the journal asks you to give an author summary, lay summary, or highlights or significant statement? Yeah, so in fact, most of you have experienced this, right? So this is the new genre of science communication. You have to not only produce science, you have to also be aware of these different communication styles. Now, I have given some examples. If you look at this, this is an extract from a paper. And it talks about author summary. We asked that all authors of research articles include 150 to 200. So it's basically like an abstract, but you have to give an author summary, which is focused more on the general public, or rather experts from different areas. So I'm not an expert of this particular, whatever the parasite or this area, but just by reading the author summary, I should be able to understand what they have done. So that's the idea of this author summary. And the next one is lay summaries, as the name suggests. It talks about like a Facebook story or a Facebook or a social media post, where you talk about the research, but in a way that everybody understands it. So that's lay summaries. And this is also from archaeological sciences reports. And then you have the next type of communication, that is about highlights. Most of you who are reading papers or engaging in science using these Elsevier papers, Science Direct, you can see these highlights often coming under the paper. So, and the worst case is most of the authors will not put proper highlights. They just, because that's a last minute preparation, they just put whatever the points they find, and which is I would say it's a waste, because you have to focus more and properly write these highlights so that your research will be cited and people get to understand what you have done. Then the next type of communication is significant statement, which states why this research is important. I have put the links as well, where you can sort of give the significance, why you have done this research, and the importance of that in the context of broader implication. Right, so these are all textual ramifications of the message that you are going to give to the broader audience. Now let me go to the next genre, which is the emerging, or rather the new communication techniques. That is this. So I'll give you few minutes or few seconds to digest what's here. And I have purposefully edited that part, the new genre of data communication rather than science communication, because this is about data. Now you can see, seemingly it's like some ocean kind of a thing. That's what I felt when I saw this first. It's about crime rates in different cities around the world. Because of its awkward nature, when you see this, you tend to go and zoom in to see what this is, right? So that's quite interesting, and attention that you give to this is exemplified with the colors and the information that you can get from different parts of this visualization. I'll show you the next one. This is population density, the first one. And just by looking at it, you can see that the crowdness or the clutter inside of a given density. So you can, or given area. You can see the dots resulting in by the population, and just by looking at it, you can get an idea which country may have higher population density. On the other hand, the right-hand side, you can see the green taxes, environmental taxes on different countries, and how it has evolved over the years. Now, these are very unique type of data visualizations or data communication in the genre of science communication. The next one is very interesting. Let me show you that. Just to hype up the interest, that's done by a journalist. And if you see this, it's really interesting. So this is the coffee intake, consumption every day for a year by using the stains of his coffee cup. So just for every day, he has just taken the coffee stains and put them there. So if you are like an art fan, you know that an artist is part of the art as well. So you have that connection between the visualization and what you do. So that's something really interesting if you're appreciating it in that way. So all in all, you can see that the genre of communication, the genre of science communication and data communication has evolved quite a lot, because we have different types of technologies and different types of data as a whole to visualize. So next part is this. So the psychology of visualization comes from the attention that we give. So for example, if you look at the left-hand side image and the right-hand side image there, you tend to feel that the left-hand side, the 4 tomatoes up front, that to the top side of it, gets more attention because that they are isolated, as well as they are colorful and they are remaining at the corner part of the visual. So psychologically, we feel that there is something with them and there is some importance. So this is the cognitive bias that we have towards visualizations. So you can use this in different ways to grab attention to what you are saying. So that's the most important thing, because the theme of today's discussion is about grabbing attention. It's not about talking to fellow scientists or fellow colleagues. It's about grabbing attention to a broader audience. So we have to deal with the psychology of the mass. So if you are trying to visualize something that is like too technical, then you will not get the same attention that you are looking for. The psychology is important when you are dealing with the mass communication. Right. So now, having that background in mind, sorry, I can't move. I'd love to move, but I can't speak loud. So when you look at the previous slides where we come to this point, I moved from science communication, data communication, to research communication. So I've taken the definition from Nature Chemistry 2011 about this graphical abstract, because I needed to focus on something related to graphical representations related to science. And I thought it's best to talk about the graphical abstracts. So I just note down that important definition about graphical abstract. It's the new online scientific genre that has been defined by the use of eye-catching visuals to attract the reader attention and increase journal visibility. So that's the definition, 2011 Nature Chemistry. But I researched about this one, and it's not like the graphical abstracts have been there from 1970. So it's not a new thing. It has been there over the years in the science communication, but we are seeing it now more often because of this, the online and digital communication is available. Right. So, but there are few limitations. There is no way or no proven method of doing graphical abstracts. So no research evidence on most effective method of doing graphical abstracts. And also they differ from traditional verbal abstracts, and what to include is missing. If you look at your graphical, I'll show you some examples. If you look at graphical abstracts from different papers, you would see a lot of biology, medicine, different types of areas in science producing graphical abstracts. But if you look at the graphical abstract, it's very difficult to understand what they are really trying to say. So the purpose is eluded. What is the real purpose of that? If this is the definition about getting the journal visibility and the attention. It's not about color, it's not about anything else, the attention. So again, the purpose of a GA is to distill the take-home message of an article into an image that grabs the reader's attention. Want to read the paper. Sometimes when we see the graphical abstract, we don't really, think that we should read it. It's very complicated in some cases. Right. So I think we built up that hype now about the genre of communication, the science, the data communication, and the research. So I'll take you to a more theoretical aspect of communication. This is called Todorov's principle. He was a famous theoretician, Bulgarian French theorist, who talks about how a story is developed. So this is important because, as I said, there is no proven theory behind how to create this graphical abstract or visual communication. But this Todorov's principle is important to build that hype. So according to him, any story would have an equilibrium point. Like imagine a movie starting point, everybody is very happy, you know, they are living happily, and maybe breakfast is there, and then there's a car coming, and they are going to the school and everything. So that's the equilibrium. Then there is a disruption. It can be an accident, it can be some personal matter coming up, a professional issue, something. And then there is a recognition, which is the actors in that story starts to identify that there is a problem, and they need to resolve this. So the repair happens, so people come together. Maybe if it is a disaster, they try to reconcile, something like that. And then the new equilibrium. So the first equilibrium and the new equilibrium, they are different. Because the purpose or the passage of events change the previous equilibrium to the new equilibrium. So that's what Todorov's principle is. So a message or a story needs to disrupt the existing equilibrium and restore a new equilibrium with a message. So that's the idea, the theoretical mean of a story, right? So your graphical abstract or your communication needs to identify this equilibrium and disrupt it and give a message to a new equilibrium. That's the way to communicate a story, right? So that in mind, let's talk about different types of graphical abstracts, the styles of communication. You can see, keep this in mind as we move on, the equilibrium, disruption, recognition, repair, new equilibrium. So the graphical abstract styles, there are linear styles, circular styles, and forking styles, and there are other styles. As we move on, I'll show you. So there's a description about the style, linear style. So here, maybe starting from the equilibrium to the new equilibrium, you are just proposing something that goes in linear in time. Maybe starting point is there's a transformation, and there's an ending point. In the case of circular style, you are maybe talking about sustainable production, cradle-to-cradle production, different types of circular economy things where you have a circle. You have an ending point and a starting point that goes as a circle. Then the forking style, like a decision theory matter, where you have yes or no conditions that move forward. The equilibrium start and the new equilibrium is reached. In between, you have the disruption with the choices that you make. And then you have the nesting style, where your message is a single entity that talks about one unique aspect of your findings. It can be a climate change issue. It can be a disaster issue where you have the graphs and everything. Maybe if it is a flood, you have the photo of a flood and some issues related to that, and then the chart that talks about the water intensity increasing and decreasing, and so on and so forth. Parallel style, on the other hand, talks about if you are doing a medical examination, you have two control case and another case where you will do the drug, whatever. Then you have the parallel concept where you have the previous equilibrium and the new equilibrium in hand to show that something has changed. And the orthogonal style, it doesn't really make sense to me, but it talks about where there is no direction. Whatever you look at it will be from multidimensional aspect. Centric style and the single or free style, these are somewhat vague in terms of the definition, but these are the things that I found where you have different graphical abstracts. Right. So these are in terms of a story, how you develop a story from Todorov's principle, how to communicate a story, to understand, digest your message, what sort of a message that you are going to develop or deliver. So to use this, you need to really understand your data visualization. So what data visualization is about. So I have brought this perceptual ranking diagram, which talks about how human brain perceives the visualizations. So if you want to give an accurate estimate of something, and I think you all agree with me as well, it's easy to look at a scatter plot or a line chart or something like that with some scales in it. So you can compare with the position and also the axis. You can read the number from there. So that's accurate information. Accurate in the sense there's a value, there is a measure. Then you have the less accurate type, position alone identical, non-aligned scales, the values are there, but because they are not aligned, you cannot compare them. That's accurate, but not so accurate as the first one. And we go down in the scale towards the general estimates, where you talk about this shading, saturation, and color hue. They are very nice, but they don't really give you an accurate number of things. If you look at a map where you have these heat maps with different colors, spots, and everything, like the red color, obviously, if there, you feel that red means something is off, something is bad. And then green color, blue color, there can be different things. But you don't know exact number of it. So they are not accurate, but they give a message, right? So having this perceptual understanding of what you really need to convey can give you a good idea of how you would develop your graphical abstract or your visual communication. That's really important. Because if you want to, let's say, for example, you need to show the danger or the hazard of a landslide to a broader area, you don't go and put values everywhere. You just show a map with some color scheme, because that conveys that there is a message, there is a danger, there's a hazard. And then you can take some out and then show a chart or something to indicate what that danger is. So this is from a previous slide. How we perceive quantitative information in visuals. Which one is more easy to understand? So I have given numbers, like the same number have been shown in different ways. So you can see value 15 in terms of saturation, volume, area, angle, length, and precision. So you can understand which one gives the best representation. If it is a color, can you understand whether that 15 or 10 with the saturation is very difficult to understand, right? You don't know what that number is. But if you look at the volume also, that's also very difficult, because volume is to the power 3, the third dimension. So you can't really understand. But the length, yes, you have an idea about the length. So that's the idea of this perceptual ranking. And again, there are histograms, stack bar charts, bar plots, line plots, etc., which I'm sure all of you are familiar with these things, but just wanted to show you that they exist. And also, depending on the complexity of the visualization, you can opt to find what is more suitable for you. In terms of the heat maps also, the colors and everything is there. Right. So that's the background of visualization. Now, this is the fun part where we talk about the guidelines of creating this infographics or data visualizations for the public or a broader audience. So the first thing is show the data, reduce the clutter, integrate graphics and text, avoid the spaghetti chart, and start with gray. So these 5 points I have jotted down here in order to develop the discussion in a way that the approach we take in developing some visual communication. And I will show you with a paper that already published. I will recreate the graphical abstract there using this computer right here. So I will show you how it is done, and I hope that we can do that. Right, let's see. So the first thing, show the data. Now, by showing the data, I mean highlight data that matters to your story. So here, this is about population. So here, you don't see rivers, you don't see roads, you don't see any other land class, land use, whatever, but only the dots indicating the population density. So what is most important in this visual? So highlight data that matters to your argument or story. If you are talking about population, this talks about that as a blueprint. Then reduce the clutter. You can see the same chart in 3D and 2D. So you can see how awkward the first one is. It doesn't really give you much of an information or any clarity in mind. If you want to compare, I think I have seen this in different presentations of different students, different postgraduate students, graduate students, different people putting up these things just because they look fancy, but they really don't make sense. Because what we really need to see is the message. So reduce the clutter. Don't overload your audience with too much of unnecessary information. Then integrate graphics and text. This is from one of my papers, where we try to show the sensor locations as well as the variation of different measurements that we took. So I just wanted to show you that we can do this, where you combine the visual that you want to show, and because here the sensor locations are important, so we took that and then we integrate the visual to that, the chart on that visual, because that relates the story. If you look at the sensor location and the chart, then you can understand, okay, the bottom sensor has this, the top sensor has this, so and so forth. It depends on how you want to communicate, and it really is a matter of art, not a matter of science. You can't just say, do this, do that. It's about the message that you want to deliver. But I can give you 3 tips. The first one is removing the legends. The legend has no meaning if it doesn't really fulfill the purpose. You can remove the legend and mark the values on the chart, then put titles and add explainers. Like for example here, zone 1 and zone 2, how and what we really want to say. See here also, likewise you can mark them. Then avoid the spaghetti chart. So spaghetti chart is this, where you have a lot of unnecessary things which really doesn't make sense, right? If you want to really focus on one particular line, one particular chart, you can focus on that, maybe by using a color, something that stand out, or hiding the other things in the background. So some of the things that you can think of when you are communicating to a broader audience. And then start with gray means sometimes you can start with a low tone to understand what you have in the data, and then highlight what is to be highlighted, right? What you need to communicate, right? For example, here you can see this obviously goes off from the chart. This is also available in our world in data. You can see the life expectancy, and this chart particularly has something different from the rest. So you can start with gray and change colors accordingly. So there's so many information in one. So I chose this particular paper, which was not by me, but someone else has published this in the Science Direct. So I thought we can do better. So I thought that this is the first time that I'm using it here, but I thought in this discussion, we can change this. And we can think of a different way of producing the same graphical abstract. So this, let's go to the paper. let's directly go to the paper and see. There's this link. Right. So it's a scientific analysis and critical review of computer vision applications for construction. And it has highlights, and then there is this graphical abstract. So when I saw this, I thought this could have been done in a different way, because it doesn't really tell you the main outcomes of it. It just gives you an idea of how it was done, but it doesn't really give you the findings of it, right? So if as a reader, I would like to see what they have found, because that's what I see that's what I believe a graphical abstract should be. So this is just the way that they have done it. And in some cases, this side space here also, it doesn't really make sense to me. I'm not criticizing them, but this is just my personal view. So I thought, why not we can change this in a way that we want it. So what I did was, so this is the paper. I downloaded the paper. And I followed their method, right? So basically, it's a bibliometric analysis, and you have this search command like computer vision or machine learning or vision systems and construction. This is their keyword. So I use the same keyword in the Scopus database to get this CSV and RIS file. So this is the CSV file that I got. So this is the basic CSV file or a Scopus database file that you get when you export the search. Right, so that's one part of their work. That's what they have done, right? So then how can we analyze it further? So I would like to see from their graphical abstract, what I don't see is like the keyword search, Scopus, article, this is there, right? And then they have used VOS Viewer to link the text. So, but I prefer to see which journal has the highest number of publication in this area and what sort of keywords have been used. So those kind of things are my interest, right? So to do that, here because I thought that this is going to be a session where everybody can use hands-on experience. So I'm going to use Power BI for this work, right? So I have to install it here. Hopefully it gets installed. It's installing it. So until that, it will take some time, I guess. So let's see whether VOS Viewer is there itself. I tried to install them early on, but still not. Yeah, that's the reason. Both of them are not here. Because this computer is connected, we can't change it. So let's see. Until that, at least we'll see what we have. All right. So, okay. Let me first give my idea about it. So what I'm going to do is, I will follow their graphical abstract, but these are the things that I'm going to do differently. one thing I'm going to do is I want to find the journals with the highest number of papers or published papers in that particular area. Here, they have not mentioned the search criterion as well, right? So bibliometric analysis depends on the search criterion, so I would like to include that as well. So this will be my changed graphical abstract. So I will include the search criterion, right? And I will also include the journals with the highest number of publications, right? And obviously I will use the same VOS. I can do it differently, but in the interest of time, I will try to use VOS Viewer for this connectivity map to show the connection. And also I'm actually looking at something of a word cluster map. That's why I need Power BI here. I want to show you the frequency of words, frequency of keywords in each of these publications. Like if you look at the publication as a whole, the cluster of keywords where this particular the authors have used. There are two types of keywords. If you go to the Scopus extract, you have index keywords, that is what the journals use for indexing, and then there are author keywords, where authors feel that this research belongs to these keywords, right? So I'm going to use the author keywords, because index keywords means that where you can find them in the journal. It depends on what you really want. So I can use either of them. So index keywords and author keywords are there. And then also, they could have included the cumulative number of publications over the years, because that also indicates an important message. So I think that should be also included here. So word cluster map. And the next one is accumulation, or the accumulation of publications. Right. So in the meantime, I could download and install 3 things. One is obviously Power BI, which I did. I could install, and also I could log into my account. And why I use that, I will show you in a minute, why exactly I need Power BI. Then I installed VOS Viewer, which I am sure most of you are familiar with. VOS Viewer is for network visualization of literature data. And I install a very handy gadget using R Studio. May I know, are you familiar with R? Those who are familiar with R, can you raise your hand, please? Okay, great. So I'm using R bibliometrics package to do the visualization for the network analysis for literature data as well, because I thought that would be handy as well, and I since I got the internet, I installed that as well. Right, great. So we have Power BI, we have VOS Viewer, and we have RStudio, and also we have this search CSV file from the Scopus website, Scopus database, where I specifically focused on computer vision, and this is the search criteria. Let me show you my search criteria. Yeah, computer vision or machine. So here, just a bit of an explanation of what that search criteria is. So these are called wild. Sorry. These are called wildcards. So here you have computer vision star, which means anything that is related to computer vision plus, and then O, machine vision, O, vision systems and construction. So anything under these O, logics and construction, anything related to construction and computer vision and machine vision systems. So article, abstract, keyword. This is what they have done in their paper. So I just did replicate the same search here. And just an indication, you have 4,364 documents for the year range from 2010 to 2023. So that's 13 years in span. And I just exported the CSV. That's how I got the CSV in my computer. So this is the CSV file. Right. So let's get back to the business. Now, the easiest thing to show you is how to connect this to Power BI, which I will be using to get the number of, which can be done with this R as well, with R bibliometrics as well. So those who are familiar with R, you can install packages using RStudio, install packages, and one such package is Bibliometrics X. That's this package. This one, Bibliometrics. So you install it, and it will install many such relevant libraries. And then if you type BiblioShiny, that's the BiblioShiny is the package that uses the network visualization capabilities, and it is a web-based application. So when you run it, it will open up in your browser. So like this. So it's listening to 127.0.0.1. This is 6.7.9.0. This is the calling. So you can see the BiblioShiny app as a web app. And you can include data from APIs and different ways. So I'm going to import or load from, you can select raw files, import raw files, right? Then it will show you what is your database. Web of Science, I think you are familiar with Web of Science, WOS, Thomson Reuters earlier, now it is Clarivate. And then there are so many other places. So I am using the data from Scopus. I'm going to take the Scopus data set, and I'm going to browse to my data source. So it should be under the data visualization camp data set. Here, this is the one that I found. I'm actually, rushing through the thing rather than showing you exact parts of the software, because these things are available online and you can learn them. Just want to guide you through the process, that's all. So once I browse to my CSV file and upload the search results, that is my CSV file, then I'm in the bibliometrics package. So when I start the analysis, it will do the analysis for the network connectivity and everything around it, and it will create one analysis out of it. So this is important, that's why I started with this. Then I'll move to Power BI. It will first of all check, this is in data science we call the most difficult part of any data science project is the starting part where we do the pre-processing. Data, we call this massaging, data wrangling, data pre-processing. So where we identify how many missing values are there and how many usable data points are there, and etc. So you can see the bibliometrics not automatically, it runs through the database, the file that I shared, and it shows how many missing values are there. So abstract, all the records are present, but there are some missing values, like author missing values are there. And science categories, obviously this is from Web of Science. If you take a WOS file, you can see the science categories, different categories, but it's not from Web of Science, it's from Scopus. Because of that, it's completely missing. And then you have keywords, DOI, that's the digital object identifier. Those values are there. And in fact, most of these data points that are required for the analysis are present here. So no issues. I can say close. And it automatically creates everything for you. So as a researcher or a person who wants to write something about a particular topic, you don't have to worry much about coding or anything else. You can just go one by one. And for example, if you go to clustering, I would like to see the intellectual structure. So co-citation network, you can simply go to that. This is, as I said, it's a very simple application. You go to co-citation network, and then if you create on co-citation network, just click that thing, and then it will automatically create one for you. So if you are familiar with VOS Viewer, this is similar to that, right? It's just a matter of click. Takes some time for the processing, but it gives you the co-citation network, right, like this. So with the clusters and who does what, and the clustering of authors, etc. Not as pretty as one would expect, but does the job for you, and it's free. You can use this. Right, that's about that. We'll come to that in a moment, but let's go back to Power BI. Why I wanted Power BI so badly, it's because of this. If you click on this, once you install Power BI, you can log into your account. It doesn't matter whether it's a paid version or not. You can use your own account as well. Only thing is that this is required when you want to get more visuals. You can click on these three dots, get more visuals. I'm really interested in this word cloud visual. That's why I wanted that so badly. So this is word cloud. So what it does is, it gives you a cloud of words with the frequency. So you can see, like if you analyze a cloud of text, a lot of text, then it will show you the highest frequency text with large size and different colors as well. So that's why I was so interested about it. And there are other visuals as well. Like there are so many other things which I haven't tested, and some of them are good, some of them are bad, but you can also try by yourself. I'm not going to jeopardize any of the future work here, so I'll just keep it as simple as possible. Right. So as I said, now I have the search results. I'm going to take in the results. So this is not a lecture or a classroom discussion about Power BI, so I'll just skim through the steps. So some of you might know it, and some of you might get an idea later. So I'm going to connect the CSV file like this. Right. Anybody who is new to Power BI, so this is a Microsoft Power Business Intelligence suite. You can use this to do different visualizations. And the advisable method is, when you import data, rather than loading data directly, it's better to go to transform data. That's what I'm going to do here. So just a little bit of a guide. So what we are doing here is actually trying to replicate this work. So this is the work that we are going to do. And don't take this in a different way that we are doing scientometric analysis here. No, I took this example because it's the easiest way for us to discuss here on the same page. If I have taken an experimental study, then some of you might be not familiar with it. And if I take a different example, maybe computer science or something else, then you are not familiar with that topic as well. But this, everybody can agree and we are on the same page. So that's why I took this example for this discussion, right? So that's why I'm just trying to replicate the same visualization using the data that we have. Right. So I imported the data, but they are not to my liking. And as you can see, any Scopus search result will result in something like this. So the first thing I would do is I'm checking on whether the data points are missing. Now, for example, this article, issue, volumes, page, and those things are not really important for me. What I'm going to do is I'm going to take a reference file here. You can do that by right-clicking and creating a duplicate. So I'm going to create a duplicate, and I'm going to remove all the unnecessary details, because my major point here is to visualize the journal. That's why I said the sketch is important when you are doing a visualization. The sketch for me was this. Search criterion, yes, done. Journals with the highest number of publications. This is what I am looking at here. So I want that plus the cluster map of the keywords. So what I would do here is I will just keep my DOIs as is, and the source title, that is the source title means the journal name, and I'm going to remove all the unnecessary columns from my duplicate. Year I would need year. Title also might be needed. And then the index keywords. So this is the one that I'm going to create a cluster of words. So I'm going to create another duplicate out of it. And I'm going to rename it word cluster. Right? And I'm going to only keep the keyword file, which is the index keyword file. You can go with the author keywords as well, but I feel index keyword, as I said, it's a judgmental case. If you feel that authors are better at defining the research keywords, then by all means you can go with author keywords. But if you think about it in terms of publishing, perhaps journals keep index keywords in a tidy order so that when you refer to them, they will maintain a consistency. So it's up to you to trade off with these judgmental cases, right? I will rely on the index keywords in that sense. So I will just remove other columns. And I have singled out my index keywords. And now I need visualization so that I can see these word clusters clearly. So what I'm going to do is I'm going to transform this into columns by delimiter. Just don't worry about the techniques that I use here. This is just a matter of doing Power BI, but I am split columns by delimiter, semicolon, each occurrence. So everything is like exploded, like in Python we say this is exploded. And next thing that I'm going to do is I'm going to put them into the same column. So you can merge, or you can say unpivot columns, and you have this with the attribute, sorry. Right? And next thing I'm going to do is I'm going to group them. group by the value, count of rows. And this will give me, just forget about the things that I did so far, but what I did was I simply took off the keywords. So I will do one by one again. So what I did was I took the index keywords column, right? This is the index keyword column with the semicolon separation. Then I splitted everything into columns like you do in your Excel. Split the columns by delimiter semicolon, right? Each occurrence of the delimiter. So I am creating a bunch of new columns. So it can, obviously, because some index keywords have, let's say, 3 index keywords, some papers might have 4 index keywords. Because of that, you are creating a bunch of null values as well, because not all the columns are equal. So you can see a lot of null values being generated. Some papers might have tens of keywords. So then what I did was, I selected all these columns from here to here, selected them, and I then unpivot columns. So unpivot means if you have, say, 5 or 6 columns, by unpivoting what you do is, you take the column identifier, which is this index keyword, this value, and put it in front of that value. So unpivot only selected column. Let's just observe what happens. So you can see the name comes in front of it, and all the values are segregated in that manner. So the title header comes as a value on the cell. So like fragmented material was inside index keyword 1.1. So everything is organized in that way, because I wanted to count them. With the columns going into that direction, it's difficult to count. So what I did was I segregated them. Then I'm going to count them. So to count them, I want to group them by unique words. So I'm going to group them, group by the value, the unique value. Then look what happens. When I say group them by value, you can say that based on the unique words, the count is generated. How many times a particular word appeared. So you can see the number of times it appeared, right? So with that, I actually created the word frequency. So that's what I did. I have created an index frequency using the number of times a particular word appeared. This is useful for me because I want to draw some conclusions out of it, right? So that's just about it. And once I finish, I can close and apply. And then I'll have visualization ready like this. Right. So now what I'm going to do is I'm going to create a word cloud. This is a very simple thing that I'm going to do here, but you can be creative, right? I'm just taking the liberty of showing you. So I'm going to create the category as the text and the values as the count. So this is the word cluster. So the number of times that word appears is shown here. So I can also go here and then exclude the rotation of the text, and this looks nice in terms of the words. So I would include this as in my graphical abstract as one way. I'll show you how to do that. So the next thing that I'm interested in is the journals. The number of journals that has published. So I'm going to create a donut chart, and on this donut chart I'm going to use the legend as my journal. So that's source title. So you can see there are many sources available. Then I'm going to create my DOI, because that's the digital object identifier that is going to be unique. So I'm going to take that value as the count. Because when you say count, distinct count, it will count only that specific DOIs, like distinct DOIs. So with that, I create this, and this is unnecessary. As I said, information visualization is as good as what you really want to show. So this is too much. I'm going to filter out the unnecessary, so I can, maybe the 10 most important journals or 5 most important journals, I can live with that. So you can go to filters, either you can use this, or you can create a filter based on the number of appearances here. Filter, you can put a DOI filter here. Basic filtering or advanced filtering. You can contain, okay, this is from the categorical point of view. Either you can just say is greater than maybe 50. Right. So with that, I have created some representation about the most number of publications present in each of these journals. So lecture notes in computer, you can, computer science, proceedings and automation in construction proceedings. So most of them published in conference proceedings, ACM International Conference, so and so forth. So it's there. Right. With that, I have concluded what are the most or rather the journals with most number of publications in that area. Right. So the next thing is about authors. I can follow a similar approach with the authors as well, where I did for the indexes, right? But I will just do a different thing here, because in the interest of time, I want to make it quick. So I'll go to transform data again. And here, like I did with the word cluster, I'm going to create an author cluster. So I'm going to, again, create a reference duplicate here. And I'm going to say author cluster. And I'm going to keep the authors like this, like I did with the keywords. And I'm going to remove all the other columns, And the same procedure, it's very simple. You split them by the column, by the semicolon. Split them by semicolon, right? And then merge them, unpivot columns, unpivot only the selected columns. And then what I do is group by the value, count of rows. Okay. So these were the authors who have published in this area. So similar thing, and I'm going to close and apply. Here, instead of creating the word cloud, I will be using simple chart, maybe something like this. And I'm going to include the authors. So I have my author cluster here. In my x-axis, I will use the authors. In my y-axis, I'll be using the count. So you can see the number of authors. And this is obviously when you don't have, say, null values are present. So I'm going to exclude them. And now I have the respective authors. Right? So they are not linked. I did it intentionally. You can even link them. So for example, if you take the DOIs separately, you can link the data set, and also if you are doing a dynamic analysis, you can click on each of these authors and see in which journals they have published as well, if you are linked the data. But I haven't linked the data here because I am more interested in the graphical abstract. And here also, I want to get the maximum, rather the best authors, or rather the people who have published here. So I would say more than, greater than or equal to, I would say 30 papers. No, 30 is too much. Let's say 20 papers or something. Oh, it's too much, yes. Let's say 50. Right. All Chinese names, but anyway. So these are the sum of count by value. We can do demographic analysis as well, right? But I will do that using R, just to show that we can do many things using many tools. So, right, this is done. And how do we convert, take this visual and use this in our graphical abstract? That's the concern I get most of the time. So how do we do that? There's a very simple fix to that. I mean, there are many fixes, but as I said, my discussion here is about contemporary mass scale communication. So you can do this by clicking on publish, and it will save in your Microsoft Power BI account. So I'm going to save it as RW, this is for Research Week, nothing else. So 04, and I'm going to save it here. It should be saved in my workspace. I'll just save it there. Right? So once it is saved, let me show you what happens. It will be published to my Microsoft Power BI account. So if I go to my account and show you, so these were my previous work that was there under my workspace. This should also come under that. So once you go there, actually, I'll just show you one other example. So once you uploaded your thing or published that to your Microsoft Power BI workspace, this is from a different study. So you get something like this, all right? Then you can easily export it as a PowerPoint. So once you do that analysis, you create your visual, you can export it as a PowerPoint presentation, right? So that's what I'm going to use here, because after that we can combine the work in different ways. Let me check whether this is uploaded. Still it's uploading. By the way, anyway, I will use that time to focus on the R case. So this is my network visualization of the authors, right? So I have top publishing authors in the Power BI visualization, then the word cluster about the keywords, and also the journal list, right? So this is the co-citation network, and I'm going to save it in my workspace, right? So plot was saved, right? Then I have historiograph as well, how the publications have evolved over the years. So this is a connectivity, like how one paper has connected to the other, and so on and so forth. So how many of you have heard of academic genealogy, the term academic genealogy? So when you analyze the Nobel Prize winners, you would see that the supervisors who have won the Nobel Prize, and then there are students winning the Nobel Prize after some time. So that's like the connectivity. One creating something and the other one taking it over after some time. So likewise, one paper leading to another paper, and how the knowledge has transferred from one point to the other. You can use this, but I don't think this is necessary in this one. So you can create the collaboration network as well. how the authors are clustered. So this is important if you are looking for a PhD or a postdoctoral position or something where to apply, and which group holds that, I don't know, like it's like an academic monopoly. So how this publication chart works, yeah, it depends on what you really want, but I'm not interested in that. I want, this countries, scientific production, because I had other things in my Power BI visual. By the way, you can do this with one software as well if you are interested in, but I just wanted to show you how holistically we can do this. So as you can see, this is the number of publications. You can see China dominating 6,832 publications in that area, and Sri Lanka 25, Australia 354. And yeah, you can download this one as well. It will be there. So co-citation network, and this is there. And let me check my Power BI. Still it's publishing. But anyway, I'll just leave it as is. But I will now show you VOS Viewer as well. Now, in the previous case, I created the citation, the index keyword cluster to show the buzzwords, and then author connectivity and the journal connectivity. Now I'm going to create a knowledge connectivity map with the bibliometric data. I'm going to couple that with that visualization, co-authorship network. So I'm going to use the Scopus. The Scopus file that I have. Right. Hopefully this should work. Until that gets uploaded, we'll focus on this. So I'm going to create VOS Viewer as a place where I can map the knowledge. So how things are connected. So the whole point of this exercise is to create a compelling graphical abstract for that work. That's the whole thing, not about software or anything. So just keep that in mind. And right. So I'm interested in co-authorship and full counting, so other things are not necessary. You can check that out. If you are interested in unit of analysis as countries, that is also interesting if you are trying to argue. As I said, the message is important. Now, if you are trying to argue in terms of the countries, how this works, you can create as countries. I will just use authors. And minimum number of documents an author. Next. You can adjust this, of course, not going for a perfect answer. This is the author connection, right? That's knowledge map. Or you can create, I need not the author one actually, I need the co-occurrence of citation by countries. That is much better because I have the author connection already. Just want a different visual. Right, this looks nice, right? So I have this, and I'm going to save this as, now this is the thing, JSON files. You can only save them. There are techniques, of course. You can use a JSON file to visualize, and since it's not the scope of this work, I'm only taking a screenshot and fit it in my, so I'll say country-wise. So I'm going to save it. Right, let's see whether that is uploaded. Still not there. Anyway, we'll we'll live with what we have. I have a previous, still not uploaded, right? So I'll just use the previous one, not related to this, but I'll just use this to show you how we can use it. So I'm going to export this to my PowerPoint. When I say embed live data, or I can export it as an image, I'm going to export it as an image, the current values, and exclude report tabs, only export current package. So I'm going to export it. So then this will give you an image of the visualization that you create as a PowerPoint presentation, right? So let me show you after that what you can do. So now, our task was to replicate this in a better way. So we are going to create a new one, new graphical abstract, but with new information and a bit of new finding, rather new visuals. Right, so this is there. What happened? It should be there, right there. Right. Anyway. So I'm going to take on all the images that I have created so far. So I have my co-citation network, country scientific production, right? This may not look nice at the moment, but let's try to organize them. So I think this is the presentation. Yeah, this is the one. Right. So as you export it, right, so it will give you something like this. Can you see? It's an image. The visualization that we created, it is taken as an image. So I'm going to use this one. Obviously not the one that we wanted, but in the interest of time, I'm going to use it. Right. Okay. So how do we take on these things in a way that we want? It's a very simple thing. You just clip them. So how do we clip them? You can use shapes, right? As I said, this is not about science or engineering or anything. It's just about using the available tools. So you can clip them. You create some a space for you to cover this up, and then just click on the two images, and then you will get under the shape format, fragment, intersection, subtract, or whatever. So I'll use fragment, and with that I can take this one separately like that, right? So I can put it where I feel useful, right? Like this. And for the other cases, unfortunately, the upload process still going on. Otherwise, we could have taken the authors and the journal one as well. You take them out and put them there where you think necessary, right? And I'll just delete this part. And this is the publication part, and this is the author citation network, right? So let's get back to the business. So what they have done, they have set bibliometric analysis stage 1, keyword search, scopus, and how they have done the search. So instead of that, let me show you, this is not the best, but I say it gives you a better view of the search results. Instead of just giving the scopus as is, I'm going to include the search terms. So their search term was computer vision or machine learning or vision system. So I'm going to use that text here, right? I'm going to use computer vision. Computer vision, machine vision, and vision systems. Right, and then construction, I think, yes. So this is under AND logic, right? So this is construction. So in order to make it sensible, what I would do is, I would use them, the things that inside the OR logic in one box, right? And this one in one box. So I will align them together and group them together, make it center, and then I will use this box to show what they have done. Like in the case of fork example, so I'm saying that either of these things should go with, that's the logic, right? Either of these things should go with the construction. So that's OR logic and with the construction. So I'm going to use that. I will be using to indicate that this is there. I'm not saying this is the ideal representation, but what I'm saying is we can always, that's the whole point of doing science, right? You can always think of a different way. And then I would say, to indicate that this is under Scopus website, or rather database, I can put it under the holistic view of Scopus. And now I'm going to use the color. So Scopus has this orangish color, right? So I'm going to take Scopus, put it here, and I'm going to color it based on the Scopus and put it behind everything. So with that, I've just shown that I've used the scope. You can obviously change sizes and everything, but I have indicated the search term which I have used, right? And then what it leads to is shown here. You can obviously play with it, and you can show the ramifications of it. You can decide, as we discussed earlier, whether it's going to be a linear thing or a fork thing or a circular thing, whatever the thing that you want. And based on that, you can show how you move forward. Right, here also they have given the keyword co-occurrences, but I would say they are very plain in sight. You need to add some flavor to it. So rather than saying keyword co-occurrences, you can say knowledge network or some word that gives a flavor to it and then give some meaning to it. So what sort of things you found? Now, in the case of, yeah, now this is available, so I can just download it. Let's see. Yeah, this is the right. So this is the one that we just created. The same thing, as I'm going to export it to PowerPoint. And I'm going to use these things to enrich my graphical abstract for the scientometric analysis here. And in the meantime, of course, if you want to sort of, trim out some of the things, like for example, if you don't like, so for me it's very difficult, like this is obscuring my view. If you want to cut it off, you can cut it off, or you can send it to the bottom. Like that. And if you want to write something about it, you can write like where the publication, the number of publications were present. Like if you go and search, check, here you have China 6832, right? So that's the number of publications present there. So maybe you can include the most important things. (6832). Right? So likewise, you can actually pick up the highest number of countries and maybe put them with the arrows and all. So it indicates you have actually done a thorough research about the areas and the countries where these publications were present. Right? Let's see, hopefully we can get our presentation ready. Yeah, it's there. So here with the journal cases as well, I have the journal list as well. So I'm going to use it under a new slide. And I'm going to take this one out. So one of the major things that I said earlier was not to keep the legends, because they are really disturbing. They are taking time, or rather space. So I'm not interested in the legend here. So what I'm going to do is I'm just going to take this donut chart alone and then name it. I'm doing it in a rush, so please, when you are doing it, be careful and do it, with care. Just kind of butchering it. So you can take this out, maybe fragment it, and then you can put this as a result of your Scopus search. And please, by all means, put a text, which journal is that, right? So which journal, the number of papers published. So because of the difficulty in typing and going through it, I will not do it, but you can easily put the number of papers found there, the journal, and something like that, and then name that donut chart. And also the number of the authors who are published. And since I have I don't need this one, I have the version that I want. So I'm going to get it cut on this. So some of you might find this very simple, like childish, but it has proven, and you can be more complex as well, but if you can do it something simply, then there is no point in doing it in a complex way. You can just clip it, and that's it. Just plug it in. Right, now it's about actually your story. Right, I don't know what they have found in the paper, right? By directing the flow of knowledge, what are the gaps, what are the things they found. They can indicate them easily, because I feel when I initially saw this paper, this is a very, I would say, low quality graphical abstract. There were things they could have included, and this is just what they have done. There's no message, as I felt. So, I mean, this is the workflow. You can follow the workflow, but that doesn't mean this is the message of the paper, because this workflow has been done by many others. So, the key idea is when you are presenting research to a broader audience, you have to understand that not only you, the many others are there who are good with their domain knowledge, they know what they are doing, but they don't have much of a knowledge of what you are doing. So it's up to you to bring them to your page. You have to make sure that your message is as good as what you claim it to be. If you don't, like, maybe this paper is very good, but if the graphical abstract is like that, I am not sure about their analysis. That can be a good one, but the first impression is important, right? So that is important to keep in mind. And coming back to the viewer as well, you can take the co-citation visualization and plug it here. Obviously, this is not a completed version, right? But I'm sure that this shows much better visualization of the message that they wanted to carry forward than the one that is present. And of course, this paper was about construction and machine vision, right? So why don't we put something that goes with that? So I would show you another nice search engine called Perplexity AI. Have you heard of it? So you can go here, maybe search about something that goes with computer vision and construction. So something that tells a story, maybe something like that, just to give a flavor to your presentation. You can maybe add something like that. It's not the place, but add something, and then holistically you can combine everything and save it as a figure. And that concludes your graphical abstract. Obviously, this is not the neat version. You can think of it, brainstorm it, and just as a concluding remark, there are other things that I haven't discussed here which I think are useful. Obviously, we talked about R bibliometrics for the bibliometric analysis, VOS Viewer for the knowledge network, and Power BI, I haven't really gone through the details of it. We can do many things using it. And the other thing is Inkscape. I think some of you are familiar with it. Inkscape, which is like a free version of Adobe Illustrator. So you can do all the graphical representations and designs using this that you do with Adobe Illustrator. And Inkscape. And then, of course, the R And then, are you familiar with Julia? Like Julia also has very nice visualization capabilities. If you want to check that out, you can check with Julia language as well. It is specifically designed for scientific work, and it's really nice. So you can check that out as well. Right. All in all, this is it. And I think you all can agree that we can develop this further from here to here. And with some thought, some brainstorming sessions, you can develop this further. Right. Okay, so I will, so if you have any questions, I'm here. So you can.
Hi guys, so like Dr. Sandun Dassanayake mentioned, we are opening the floor for any questions that you have, any gray areas, or any doubts that you have. I saw a lot of people taking notes, and I saw a lot of people taking a good interest on the presentation too. So if you guys have any questions, the floor is open. Get the most benefit out of Dr. Sandun Dassanayake today by asking questions and clarifying any doubts that you have. If you have any questions, just raise your hand. We'll provide you a mic, and then you can go ahead with your question.
Thank you very much, Sandun. It is indeed a very, very interesting presentation. I'm also a very big, let's say, when it comes to data visualization, I'm also always encouraging the students to go with that type of nice graphs, charts, etc., etc. And one comment which I received from one paper is when we are inserting lot of figures into a paper, some reviewers, they don't like it. So they are saying rather than include it in a graph or a figure, they expect us to give a proper explanation. I agree with all what you have presented with that graphical representation, because of course I think I also agree it is a very self-explanatory works, but there are some reviewers it's very difficult to handle. Especially in your graphical representation, now you have used around 5 different figures. So can you explain to the students when we are selecting number of figures into a graphical abstract, what type of strategies that we need to follow?
Right, it's a good question, because it's actually about this auditory intelligence and visual intelligence. Like some people think visually, some people think auditory. So when you are explaining I'll come to the question, but in terms of a background check, so depending on the journal, depending on the viewership of the journal, this depends. Like sometimes when you are looking at a physics journal, they prefer visualizations because some complex mathematical stuff, it's very difficult to explain in using words. So you need some visual, some change in colors and things like that. But when it comes to like policy, law kind of a thing, they need research question 1, research question 2, what is that, what is this? So it depends on the readership and the editors and the reviewers, yes. But coming back to the question, if you are referring to the number of visuals or visual items, I think it's about cognitive load. Like if you are referring to someone who is not of a visual intellect, then obviously some people also get it very difficult to focus. If you have more than 3 items, it's very difficult to focus on each of them. So better to restrict it to 3 items maximum, and go with text and visual all together, because 3 items, as it's a rule of thumb, it gives you the context as well, because you have the problem, methodology, and the finding. So if you focus on these 3, the introduction of the problem, let's say looking at disasters or something, you can just give an image about the disaster or the that context, and then the methodology may be a flow diagram or something, how it was done, and the third thing about the result. So 3 images, 3 visual items would be enough. But coming back to that query about the reviewers' comments, so I also had this discussion with an editor. So what they referred there is that if you are looking at a half a page figure, they want a figure to explain some concept around 450 to 600 words. So if you are trying to load the figure with more information than that, then actually that figure is too cluttered. So one thing is to make sure that you think about, so as I said, it's an art more than a science. So if you think about three key points that you want to convey, then focusing on those three messages only would be the best, in my opinion. Like, for example, if you want to show that, say, China has the most number of publications here. So just focusing on that in terms of the demography and the number of publications, that would be much better than just focusing on the entire globe and talking about it. And yes, that problem is there because it's about judgment. Because most of the time, some reviewers don't like to, read. Some reviewers like to look at the figures. And I would say, in terms of the balance, it is better to have like a balanced approach rather than like, say, 6 figures to 5 figures in a journal article with an abstract, so GA, graphical abstract one, if it is, because most journals require graphical abstract in nowadays. They say you can include a graphical abstract. Because for some infographics and some maybe putting an X message or some social media campaign, that would be useful. And for your presentations as well. Yeah, that's what I feel. Like 3 visual elements would be much better. And here also I have just included too much just to show you that this can be done. But yeah, you can focus. For example, if my key message here is that the computer vision plus construction is not in construction journals, then I can show you that, because most of these journals are not in the construction area, mostly in the computer science area. So something like that. If that is the message I want to say, I can focus on that.
Thank you. One question. Now there are most of qualitative researchers in this room now. Can you recommend few visuals which we can use using Power BI to present qualitative findings rather than all these which we can play with the numbers? There are a lot of qualitative findings which we need to present using a nice visual. So can you recommend something like now?
Right. So I myself is not into qualitative research. So I'm not really familiar with that because of that. But I see that sunken diagrams they use a lot. And the word clusters I have seen them using. Apart from that, actually, I don't have much of an idea about what sort of a visual is more suitable for a qualitative.
Like code diagrams in Power BI, and Sunkey one of the,
Yeah.
and also we can use this world map clusters. So likewise, any other visuals which you can recommend?
To be honest, I haven't used any of them. So you can search for them here under the visual, obviously from the Get More Visuals. But since I haven't tried them out, I can't really be sure. Because in one way, like some qualitative research, I think they again convert it to quantitative elements to get the visual done. So like in the case of here, you may be converting this frequency to a number and then show it as a bar chart or something. And if it is a Likert chart or an AHP, again you have to show the heat map or something to show. So again coming back to the same type of visual. But anyway, I think Sunkeen, right? Yeah, so that is what I have seen. Apart from that, geospatial visualizations, I have seen, yeah, this one. This, like a hexagonal visualization of a spatial thing, I have seen this. So something like this was also nice, because one thing is, I'm not using Power BI for these kind of things. I'll be using either R or Python. So to cluster them according to the hexagons. So this is another spatial visualization where you don't have to worry about the boundaries, the administrative boundaries. You just take hexagonal because it's equal in all directions, distance. So you put these blocks and then show the densities, kind of. So this is also nice, but I haven't used this in Power BI.
Thank you very much. Thank you very much for your comprehensive presentation, sir. I have a small question. When we are going to most of the conferences, they ask us to submit sometimes this graphical abstract, and there are some competitions related to these posters. So what is the difference between the graphical abstract and the poster?
Okay. So, this is not a proven knowledge, but this is from my experience. So, the difference is the person, because a poster doesn't exist alone. So, always there is a presenter for a poster. So, a graphical abstract is a standalone publication. So, that is the main difference I see. So, if it is a poster, even in the poster cases also I have seen a lot of text being included in the poster, which is unnecessary. So in a poster, you can, like in a 3MT presentation, you have seen, I think most of you are familiar with three-minute thesis presentation. So there, if that poster contains the information flow, the method and the findings, etc., that is, the person can explain it because the person is there for that. But in a graphical abstract, you have to make sure the message is clear, like in a written form. So anyone who is looking at, because just the arrows will not do. You have to make sure that it is readable and the message is clear. So that's the difference. So in my opinion, for a poster, you can always, replace the voice. Someone will be there explaining. But in a graphical abstract, you have to make sure that the message stands out. That's the difference.
Right. So I would like to thank the resource person for the day, Dr. Sandun Dassanayake, for conducting an amazing session, which is very interactive, very engaging. I saw a lot of people taking notes. I hope it's interesting, as well as it teach you something that will be definitely important when you are going through your research journey ahead. Probably you might be using the softwares and other techniques that Dr. Sandun Dassanayake has mentioned today. So while using, you may come up with some problems that may be needed to sort it. So at that time, always you can ask from someone who knows it. So even though it is not the healthiest day for Dr. Sandun Dassanayake, he just came to Research Week 2024 and patiently delivered an amazing session for us. So I think that should be appreciated. We should show our gratitude. So to show our gratitude and to appreciate his service today, we would like to present some tokens of appreciation. So to present the tokens of appreciation, I would like to invite once again Dr. Naini here to present the tokens of appreciation to our dear resource person, Dr. Sandun Dassanayake. Sandu sir, please remain. There is another token, I guess. There is a plant from Turu as a token of appreciation. Thank you, sir. Thank you, madam. With that, we are reaching the end of the data visualization camp, the first session of the day 2 of Research Week 2024.